Hey guys, today we're learning about how to simplify exponential expressions. Hey guys, and welcome back. If you haven't done so already, go ahead and subscribe to my channel. That will be helping me a lot. And if you know someone who needs this note, go ahead and share it with them. Last time we talked about algebraic expressions and we gave a few examples. Today we are going to dive deeper into how to simplify them, especially how to simplify exponential expressions. When you think about exponential expression and how to simplify them, you should think of the order of operation. Usually, students will remember the order of operation by the acronym PEMDAS. That's PEMDAS. And this stands for parentheses, exponents, multiplication, division, addition, and subtraction. The words simplifying and evaluating here mean the same thing, to rewrite the expression to its simplest form. But the word evaluating is only reserved to simplifying expression that is made of numbers only. So in this particular note, we're going to learn how to simplify or evaluate exponential expressions. And the first thing we need to do here is to give you some rules about exponential expression that you should keep in mind when you go through the example that we're going to be going through. The first rule is b to the power of 0 equals 1. This tells you that for anything that's raised to the power of 0, the answer is always going to be 1, except for 0 itself, because 0 to the power of 0 doesn't exist. The second one is going to be b to the power of negative n equals to 1 over b to the power of n. What this is telling you is that in order to change the sign of an exponent, all you have to do is bring the exponential factor either from the numerator to the denominator or from the denominator to the numerator. The third rule is going to be b to the power of n, b to the power of m equals to b to the power of n plus m. So if you have exponential expression with the same base, you can add up the exponents and make it one base. The fourth one is the same as the third, but it's for division. So if you have exponential expressions that are dividing each other and have the same base, you can subtract the exponents to make one base. The fifth one is going to be a times b raised to the power of n. For this particular one here, in order to remove the parentheses, all you have to do is share the exponent to all the factors in the parentheses. So you're going to have a to the power of n and b to the power of n. The next one is going to be the same as the previous, but it's for division. Again, to remove the parentheses here, you can share the exponent to the top, the numerator, and the denominator. And the seventh rule is going to be b to the power of n altogether to the power of m. So when you have two exponents like that next to each other, you can remove the parentheses and multiply the exponents through. So you're going to have b to the power of n times m. All right, that's all for the rules. And then let's look at some examples to see how those apply. The first example here is going to be negative 3 to the power of 2. And since the whole thing is raised to the power of 2, you're going to have negative 3 times negative 3, and this should give you 9. And the next one is going to be negative 3 to the power of 2. So I have these two examples here to show you the difference between when you have parentheses and when you don't have parentheses. In this case, the negative is not affected by the square, and so you're going to have negative on the side and 3 raised to the power of 2. And so you're going to have negative 3 times 3, which is going to be negative 9. Next, we have 3 to the power of 8 divided by 3 to the power of 4. For this particular one, we're going to use rule number 4, and you see that you have the same base here, 3, and the powers and the exponents are 8 and 4. So in order to simplify this or evaluate it, in this case, you're going to have 3 raised to the power of 8 minus 4, which should give you 3 raised to the power of 4, and that should give you 81. Okay, let's look at some more complex one involving variables. The next one here is going to be negative 9 times x to the power of 4 times y. Altogether multiplied by negative 2x to the power of 5, y to the power of 3. And so here you have factors that are multiplying each other. And so you're going to have to use rule number 3 here, because you have x and x on both factor, you have y and y on both factor, and so you can add up the exponent. But let's start with the numbers here first. So you have -9 and -2, and that should give you 18, and then x to the power of 4 and x to the power of 5, and that should give you x to the power of 9, and then y to the power of 1 and y to the power of 3 should give you y to the power of 4. Next one here is going to be involving divisions. So we have 25 times a to the power of 13 times b to the power of 4, all divided by -5, a to the power of 2, and b to the power of 7. And so that should give us, if you look at the numbers first, and using rule number 4, you're going to have -5 times a to the power of 11, because that's 13 minus 2, times b to the power of -3, because that's 4 minus 7. Now, when you use rule 2 here, you can turn this b to the power of -3 and bring it to the denominator to change the exponent sign. Because in math, whenever you are simplifying an expression, it's usually preferable to leave them without negative exponents. And so you're going to have -5 times a to the power of 11 divided by b to the power of 3. Our next example is going to be -10 times b to the power of 8 divided by 30 times b to the power of 2, all together raised to the power of 2. And so here we're going to do the parentheses first. And so we're going to have b to the power of 6, because that's 8 minus 2, using rule number 4. And then dealing with the numbers here, we're going to have -10 and 30, giving you -3. So that's going to be -1/3 times b to the power of 6, or you can write it as b to the power of 6 divided by -3. And so then, using rule 6 or 7, you can share the exponent 2 to both of those factors. So you're going to have b to the power of 6 times 2, which is going to be b to the power of 12, and then -3 squared is going to be 9. And so then you'll be done. And the last one here is kind of a bonus one. And so you have 3 times a to the power of -5 times b to the power of 5 times x to the power of 10, all divided by 12 times a to the power of 3, b to the power of -4, x to the power of 6, all together raised to the power of 0. So when you have this, you can start by doing the parentheses and try to simplify those by using rule number 5 and 6. But you could also just realize that this is one big term that is raised to the power of 0, and that should give you 1. Now, in this note, I've been mentioning factors a lot, and I haven't talked about it yet, but you know what terms are. In an expression, terms are separated by pluses and minuses. In an expression, factors are separated by multiplication signs or division signs. So that's the difference between the two. So in this particular case here, we had a bunch of factors, and when before, in the previous note, we had a bunch of terms there because we had a bunch of pluses and minuses. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.